Welcome to Creative World. In this video, we will solve Chapter 3 Learning Assessment E3.4. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Learning assessment E3.4. Find the node voltages in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find these two node voltages labeled as V1 and V2 using nodal analysis. So without wasting time, let's proceed towards the solution. We know that in order to apply nodal analysis on a network, we have to follow some steps. First step is to count total number of nodes present in the network. In this network there are three number of nodes. One of them is reference or ground node. Other two nodes will be utilized for the implementation of nodal analysis. In second step we have to label all node voltages. In this case it is already given in this scenario. These two node voltages are labeled as V1 and V2. In third step, we have to assume and label all unknown branch currents along with their directions. In this network, current through these three branches is already provided in this scenario, so we have to just assume these two branch currents. I am assuming currents through these two branches as current I1 and I2, and this current I2 is leaving from this node V2 and I1 is leaving from node V1 and entering towards V2. We have completed all steps of nodal analysis. Now we will implement nodal analysis technique on this network to find out node voltage equations. Now this network includes three number of nodes. Out of three nodes, one is reference or ground node. So remaining two nodes will have two node voltage equations. So there will be total two number of node equations inside this network. So first we will apply Kirchoff's voltage law on this node. At this node one current is entering 4 milliampere while two currents are leaving. One is I1 and other one is I0. Entering current is taken with positive sign while leaving currents are taken with negative sign. Now in next step we have to replace these two currents with their respective equations. Current I1 is leaving from node V1 and entering towards V2. It is indicating that node voltage V1 is on higher potential than V2. So current I1 through this 10 kilo ohm resistance will be equal to the potential difference across these two nodes divided by the value of resistance V1 minus V2 divided by 10 kilo ohm. Similarly, current I0 will be equal to voltage across this 10 kilo ohm resistance, that is V1 divided by the value of resistance. So current I0 equation will be V1 divided by 10 kilo ohm. Now we will simplify this equation. In order to omit denominator values, we will multiply this equation on both sides with 10 kilo ohm. Product of 10 kilo ohm and 4 milliampere will result 40 volt. Milli will cancel out with K. And here product of 10 kilo ohm and V1 minus V2 divided by 10 kilo ohm will result V1 minus V2. Product of 10 kilo ohm will cancel out with 10 kilo ohm in denominator. And same case will be here, only V1 will left. Now open these brackets and place this constant on the other hand side of equal. It will become minus 40 volt and this minus will multiply with values inside the brackets. It will become minus V1 and plus V2 minus V1. Now this minus V1 and this minus V1 added together, the equation will become minus 2V1 plus V2 equal to minus 40 volt. This equation cannot be further solved, so we will leave it for now and will label this equation as equation A. This is the first node voltage equation of this network. Now we will apply Kirchoff's current law on this node. On this node, one current is entering, that is I1, while two currents are leaving. One is the current of this branch, that is 2 times I0, and other one is I2. So entering current is taken with positive sign while leaving currents are taken with negative sign. Next step is to replace these currents with their respective equations. Current I1 is equal to V1 minus V2 divided by 10 kilo ohm, which we have calculated in previous step. Similarly, current I0 is equal to V1 divided by 10 kilo ohm. And current I2 will be equal to V2 divided by 10 kilo ohm because V2 is appearing across this 10 kilo ohm resistance. So modify the equation by replacing all these currents with their respective equations. Now in order to further solve this equation, we will multiply this equation on both sides with 10 kilo ohm. Product of 10 kilo ohm and V1 minus V2 divided by 10 kilo ohm will result V1 minus V2. Product of 10 kilo ohm will cancel out with 10 kilo ohm in denominator. Same case will be applied with these two values because both values have 10 kilo ohm in denominator. So the equation will become V1 minus V2 minus 2 times V1 minus V2 equal to 0. Now take the product of 2 and V1. The equation will become V1 minus V2 minus 2V1 minus V2 equal to 0. Now subtract V1 from minus 2V1. The answer will be minus V1 because large value have minus sign along with it. And sum of minus V2 and minus V2 will result minus 2V2. This equation cannot be further solved, so we can label this equation as equation B, and this will be the second node equation of this network. So up to this point we have found two node equations of this network. Now we will solve these two node equations in order to get node voltages. Here if we take equation B as it is and multiply equation A with 2 and add that resulting equation with equation B, we can find the value of V1. So first of all we have to multiply this equation A with 2. The resulting equation will be minus 4V1 plus 2V2 equal to minus 80 volt. Now we will add this resulting equation with equation B. This minus 2V2 and plus V2 will cancel out with each other. Only V1 variable will left inside this equation. So we can find out its value. Minus 4V1 and minus V1 will become minus 5V1. On the other hand side of equal, minus 80 plus 0 will become minus 80 volt. Now in order to calculate the value of voltage V1, we will divide on both sides with minus 5. The value of V1 will become 16 volt. After getting the value of voltage V1, we can place this value inside this equation B in place of V1 to calculate the value of voltage V2. So place value of V1 inside this equation B. V1 is replaced with 16 volt. Now in order to calculate the value of V2, we will place this minus 16 volt on the other hand side of equal. It will become plus 16 volt. And divide on both sides with minus 2 to calculate the value of voltage V2, that will become minus 8 volt. So the values of node voltages inside this network is V1 equal to 16 volt and V2 is equal to minus 8 volt. This was learning assessment E3.4. Thank you. See you again in next video.